Alright, this video is going to explore the algebraic and geometric solutions or ways of solving this particular equation. What we notice is the left-hand side has square roots, which will sometimes intimidate people, but I know how to make them go away by squaring. On the right-hand side I have fractions, which will sometimes intimidate people, but I know how to make them go away by fraction busting. But before we get to the algebra for finding the solution, the values of x that make this equation true, I'm going to look at the geometry and see what happens if I explore graphing. On the left-hand side, I can see from just a simple modification that there's going to be a horizontal compression of the square root graph, and it will be shifted to the left 1. And on the right-hand side, I see a line whose slope is 2/3 and whose y-intercept is also 2/3. But to the left-hand side, I shift the vertex, the starting point for the square root over to the right, left 1. And then instead of going up 1 over 1, I go up 1 over a half. And then I use those 2 points, along with the nature of a square root graph, to get this graph shown here. And I actually use 2/3 as my y-intercept. And if I go down 1, if I go down 2/3, I'll go back 1. Or we could say over 3 up 2. Either way, I'm able to produce this line. And what we can see from the graph right off the bat, when x equals -1, it appears both graphs intersect. But it also appears if I extend this curve a little bit, looks like x might intersect at around 3 maybe. But I did have to curve downwards to get there, so maybe it'll be slightly larger than 3. Anyway, as I continue, now we start looking at the algebra. And once again, I'm going to point out that in this case, the radical is something I want to go away, but the fraction is something I want to go away as well. And we can make both of them go away if we're just patient. I'm first anxious to get rid of the fractions. So to do so, I'll multiply both sides of the equation by 3. And when we distribute the 3 on the right-hand side, we get 2x plus 2, so there's no more fractions. And on the left-hand side, we just need to be aware there's nothing we can do. We just have to leave it as 3 times the square root of 2x plus 2. Now I'm going to do what it takes to get rid of this radical. I'm going to square both sides, but we have to be careful that we are actually showing the square of both sides, including the 3. There are some people that will just put the 2 up there, get rid of the radical, and leave the 3, or ignore the 3, or make it disappear, or whatever. But remember, we have to square it. So 3 times 3 is 9. Square root of 2x plus 2 times square root of 2x plus 2 is 2x plus 2. And then over on this side, do not forget to FOIL. That's going to be 4x squared plus 4x plus 4x plus 4. And that combines to give you this expression. After distributing the 9, I recognize, even before I distribute the 9, I have quadratic form, and I'm going to try to use factoring to solve this quadratic equation and hope for the best. So first, I need to use the zero product rule, which means I need this expression over here equals 0. So in so doing, I'm going to subtract 18 and subtract 18 acting on both sides of the equation, producing this quadratic. Before I start thinking about factoring, I recognize 4, -10, and 14 are all even numbers, so I'm going to divide both sides by 2. And that makes smaller coefficients, which makes it easier to factor, and the rest of this is a review of factoring. And right here is the zero product rule. That's what enables me to separate into 2 separate equations. And I found 3.5, which is close to my prediction of 3. In fact, if I extended my graph, the black one, I sort of made it intersect at 3 because I wanted it to be 3 for a solution. But if I really was being honest and extending my graph properly, I'd see 3.5 is much more reasonable. Just to be sure, right down here, I'm going to be substituting 3.5 in for x, 7/2 in for x, and hoping that they're the same, which they are. So I know these are the right solutions. But just in case there's any doubt, I went to Desmos, and you'll see in this grid in the back, this is the actual Desmos green line, which corresponds exactly perfectly with my line. And even the x and y axis are almost overlapping completely. Here's x equals 2, which is following right on. And then the black curve is completely covered by my graph until you get out to here. You can see how well that lined up. So I was really proud of myself. Anyway, these are the 2 solutions. I've checked it with technology. I've checked with manual labor. The bottom takeaway here is before we start getting rid of the radicals, we can do some cosmetics to the equation, which would make our number work a lot easier in the long run.